Okay, there's more. Wait, I'm getting Google's public key from .com. How do I get .com's public key? What do you think? Anyone want to answer in chat? Sweet, query the root DNS servers. Yeah, same way that I get .com's, like the IP address for .com's name server. I ask the root name server. Same thing, when I ask the root name server about .com, I'll ask it not just for the IP address, but also for a public key, okay? So there's this hierarchy of certificates that's rooted in the public key of the root name server. So wait, how do we know the public key of the root name server? This one's a little trickier because there's no one else we can ask. So where does this recursion, what's the base case? How does this recursion get started? How do we know the public key of the root? Sweet, hard code it. Yeah, build it into your software, build it into the resolver. It's configuration, or it comes with the client's software. There's a well-known place. Absolutely. Yeah, there's no other option. That's the only possibility. That's exactly how the software works today. When you download a DNS client or a DNS resolver, it has hard-coded in it the public key of the root name server. Okay, good. So you really don't want to change that very often. All right, so let's think about how the resolver verifies. Now, we should really think it's not just one certificate with a response, but this chain of certificates. There's this answer from google.com, and an answer from .com, and an answer from the root name server. And how are we going to verify that? Well, we're going to go through and verify each of them one by one. We're going to get information about .com from the root, and we're going to verify a signature on that. And then that'll tell me .com's public key. And then we're going to get information about google.com from .com, and we're going to verify that using the public key for .com that we just got. And then that'll tell me the public key for google.com, and I can now verify the response I got from google.com. Good. We're on a good path here. Now I want to consider another tricky case. So far we've been considering the case of DNS queries where there is an answer, a positive response. We ask for a host name that exists, and we got back an IP address. What about when we issue a query for a host that doesn't exist? Like we queried the name server and we asked for dog.google.com, and there is no host name named dog. It's a little tricky to think how to handle this. Well, the answer that we're going to get back is probably actually not an IP address in this case, but the answer saying no such host. How are we going to verify that? When we get back a response that says there is no such host, that's correct and has not been tampered with? Any ideas? How would we verify when the answer is no such host? Can we use the same? Yeah, let's sign a record. Let's do the same thing. We could sign a response that says there is no such host. Okay, that's a perfectly reasonable design, and that's a very natural thing to do. Now let me talk a little bit about caching. Remember how I said caching is really important to DNS? Let's think through all of this design we've been building up and figure out how well it works with caching. Is it going to work with caching? I think the answer is, for most of what we've been saying, yes, is going to work great with caching. The google.com can sign ahead of time a response for how it'll respond for each of its host names. So it can sign a response that says the IP address of business.google.com is such and such, and sign another one that says the IP address for finance.google.com is such and such, and another one saying the IP address for mail.google.com is such and such, and then keep those around. And then anytime someone asks for mail.google.com, send back that pre-signed request. And the recipient can verify it and cache it and send it on to someone else, and this other person will be able to verify it. So far, most of the design has been really great from the perspective of caching. The name server doesn't have to do any kind of signing on the fly, and you can retain data, and it has all the information needed to verify it, so you can cache it. But we just introduced a twist here. When we said, when the answer is there is no such host, so we're going to sign that. it's a perfectly reasonable design, but unfortunately, the consequence of that design is now the name server for google.com is going to have to sign those on the fly because it can't predict all possible non-existent host names that it might ever be asked about. Okay, so when it gets a query for a non-existent host like dog, it's going to have to say, oh boy, I better generate a record that says dog.google.com does not exist and sign it right now on the fly. Okay, and unfortunately that's expensive. That's a slow operation. And it would be really, really nice if we could come up with a way to spare the name server from having to do that. Why might we want to spare the name server from having to do that? Why is it bad if the name server has to sign these no such host responses on the fly? What's bad about that? Yeah, I like the answers I'm getting. Performance, the signature signing is slow. This could cause too much overhead if the name server is getting a lot of queries and it's getting thousands of queries that are for non-existent hosts. It could cause denial of service. A way to really just cause the name server to become overloaded is just send it as fast as you can. Send that name server queries for lots of non-existent hosts, lots of different non-existent host names. And I can generate those queries a lot faster than the name server can sign them. So that'd be a denial of service problem, absolutely. Also, it's not so great for security. It's maybe less than ideal for security because it means the name server has to have that private key sitting in memory kind of available to use online, which maybe is okay for the server for google.com. But if you're thinking about the server for like the root, you might not want to have that on an internet connected device. Just like you might not want to have your Bitcoin wallet sitting on an internet connected device. You might not want to have the private key for something so really critical like .com or the root sitting in memory on a server that's internet connected. Maybe what you'd want to do is be able to sign stuff offline and then transfer the signed records onto the online server. So if the online server gets compromised, at least you haven't lost your private key. Well, that's no longer possible with this design for handling responses for no such host. So yeah, denial of service, performance, potentially security all mean that it's kind of sad that we have to sign on the fly for negative responses.